Alrighty. So this lesson is 6.3, which we are solving multi-step inequalities. Um, the last day or so, we were able to solve inequalities by using addition and subtraction, and also by multiplication and division. Sections 1 and 2, we just did the one step. Today we're going to do multi-steps, so probably 2 steps, possibly 3. So keep that in mind, what we learned from using one-step inequalities and applying to the multi-step inequalities. And also don't forget the weird rule, which means if you multiply or divide by a negative number, you must again flip the inequality. So let's look at example 1. Example 1, they want us to graph or solve and graph the inequality. So we have, our example is 3x minus 7 is less than 8. So I'm still going to do the same things whether if this would still look like 3x minus 7 equals 8. I'm still solving for x. The only thing that changes is that we have an inequality in there. So I'm going to add 7 to both sides, because the first thing you do is work with the non-variable numbers. So that gives you 3x is less than 15. Next, I'm going to divide by 3, which then gives me x is less than 5. So again, graphing the inequality is the same thing we did like in sections 1 and 2. I got 5, I got 6, I got 4. Since it's a less than sign, it's an open circle, and I am shading to my left. So it's okay. Let's look at B. So B is we have, I'm going to, let me extend this a little bit. Yeah, that's a little better. So I have some room to work with. So I have negative 0.6 times quantity x minus 5 is less than or equal to 15. So first thing I'm going to do is I'm going to distribute at negative 0.6 to my x and to my negative 5. So when I distribute, I'm going to multiply, so I get negative 0.6x plus, it would be, it's here, 0.6 times 5 is 3. And so I had a negative times a negative gives me a positive, so now I'm going to less than or equal to 15. Now I'm going to subtract 3 to both sides. That cancels, which gives me negative 0.6x is less than or equal to 12. And now I have divide both sides by negative 0.6. So 12 divided by a negative 0.6 gives me negative 20. So I have x, but because I divided by a negative number, I shall flip my inequality. So now it is x is greater than or equal to negative 20. So as I graph my inequality, I'm going to go negative, oh, I'm sorry, this should be 19, and this is negative 21. We have a closed circle, and my inequality is to the right. Let's do one more example for this section. So I have 6x minus 7 is greater than 2x plus 17. So what I want to do is I need to get combined like terms. So I see I have x on both sides. So I'm going to subtract 2x here, subtract 2x here. This cancels, and 6x minus 2x gives me a 4x. So now I'm going to drop down my minus 7 which is greater than 17. I'm going to add 7 to both sides, so that cancels that out, and that leaves me with 4x is greater than 24. Now all I gotta do is divide both sides by 4, which then gives me x is greater than 6. So I have 6, 7, and 5. As I graph my inequality, it is a open circle, and I'm shading the right-hand side of my number line. The next portion of this assignment deals with identifying number of solutions of an inequality. Sometimes it doesn't matter what you put in for your x. You can sometimes get no solution or all solutions. Here are two examples. I got a here and I got b down here. So let's look at a first. So I have 14x plus 5 is less than 7 times quantity 2x minus 3. So what I'm going to do is I need to solve for x, but so I'm going to do is I'm going to keep that 14x plus 5 is less than, but now I'm going to distribute that 7 over the quantity 2x minus 3, which leaves me with 14x minus 21. I need to get the common variable, so I'm going to take negative 14 to both sides. It actually cancels both, which leaves me with 0. And I'm left with 5 on the left-hand side. I got my less than sign and negative 21. So what it tells me is that the statement is made is 5 is less than negative 21. Is that a true statement? No, it is not, because 5 actually is greater than negative 21. So this statement right here is a false statement. And if we've come across a false statement, that means that our variable x has no solutions. There is no solution for x that will make this statement true. And if you find yourself with x having no solutions, you do not have to graph your inequality. So if I bring it down to b, this is an example of the other way around. It would be a true statement. So we have 12x minus 1 is greater than, I'm going to distribute my 6 over my quantity 2x minus 1, which gives me 12x minus 6. So I'm going to subtract 12x to both sides, which that cancels out, which makes it 0, which now I have negative 1 is greater than negative 6. Is that a true statement? Yes, it is. It is a true statement. Negative 1 is greater than negative 6. So I can conclude that this is a true statement. And if it is a true statement, that means that all solutions for x are true. So when you graph a equation that has all solutions, it looks something like this. You want to shade the entire number line to establish that it doesn't matter what number you put in for x, you will get a true statement. And that is how we solve multi-step inequalities. And I hope this helps. And until next time.